Um, I I know that some of you are not happy with your quizzes. By the way, we got the okay for you to turn your cameras on, so um, I would like you guys to start doing that at this point. It would be nice to be able to see your faces. And like if I ask yes or no questions, I can see again, like you shake your head or no, you don't need any help or you don't have any questions. The one thing that I want to go over really fast is I know that you didn't do well on your quizzes yesterday, but you're making it a little bit harder than what it is. And I know you're probably thinking, she's lying to me. This was really hard. It's not. You, you, I don't know. You're not asking, there's like 3 or 4 of you that are asking questions. And then it's like, when I ask you to ask questions, you just don't. You guys have to be transparent with me. I told you that on the opening days or the orientation days, that I need you to be transparent with me. If you're not getting something, interrupt me. If I'm going too fast, interrupt me. Guys, it's honestly okay. All right. And again, we're all in this together. So I think almost everybody in this class emailed me yesterday. So that tells me you need to make sure that you pay attention here and you need to ask a lot of questions. Don't feel bad. You would ask questions if you're sitting in class, ask questions if you're on this. And I know this is, again, not the best situation, but it's what we have to work with right at this point. Okay, so what I'm going to do is I have a separate sheet of paper out from my notes, and I'm going to write down a couple equations, and I'm going to show you guys how you should have done your quiz yesterday. It is really simple, so don't freak out about it, okay? So I'm going to, oh, I got some chat. Can everybody hear me or no?
Yes.
Okay.
Yeah.
All right. So if I'm ever on here and y'all see me talking and you're not hearing anything, yell at me, let me know. I think everybody's in. Okay, Sam, I'm not sure what's going on. Okay, so I'm gonna share my screen. I gotta get my apps up. This may take a minute because it was really weird just a second ago. Let's see. Sorry, y'all. Okay. All right, is everybody good seeing the notes or seeing my paper?
Yeah.
All right.
Yeah.
So your quiz yesterday, and I'm gonna try to get all this settled down. You had equations like this: y equals 2 times x minus 4 plus 3. You had to identify the type of equation. So just so you know, if it's a single x and not an exponent, it's a linear equation. If it's x squared, it's a quadratic equation. Okay. If it's absolute value of x, it's absolute value. Oh, sorry. And then if it's like a number to the x, that x is a power, it's your exponential. So those are the 4 different types. I don't think that you're having problem with that. This one is the only one that I've seen being missed, and you guys are putting linear. Make sure that you see that it's actually an exponent. So what is this? What is this function? Which one is it?
Linear.
Linear, because it's a single x. So then I asked you about the vertex point, and some of you are telling me that there is no vertex point. Yes, there is. You have to understand that linear does have a vertex. It's like a master point when you write it like this. So it still has that vertex point. It just doesn't have the actual coordinate point. Exponentials also have that point. Okay, so we need to make sure that we understand that there's always going to be that vertex point when it's in vertex form. So here we go. When we take the vertex coordinate and we pull that -4 out, we have to change it to positive. Some of you guys saw change x, keep y. So there's your change x. So your vertex coordinate starts with a +4. We keep y, which means we just bring down the 3. That's your vertex. Change x, keep y. Then it said tell the transformation. This tells you the transformation. How did I get there? How did I move from the origin? So from 0, 0, what directions did I go?
Right.
Right.
4, up 3.
That would have been your quiz answer. That's it. Okay. So some of you are asking about all those negatives and reflections. This one didn't have a reflection because it didn't have a negative on the 2 or with the X. So there's the 2 places you'll find them. It'll be either in front of the 2 or in front of the X. So this one didn't have a reflection. Guys, you got to start being on time. We have 2 to the negative X plus 6. That's a full exponent. And then we come back down to regular and a minus 4. So what type of function is this?
Exponential.
What is your vertex point? Same thing. Whatever's with X, you change the sign. So it's a plus 6. So your X is going to be negative 6. And we keep the end number, which is negative 4. That's your vertex point. Then for your translations, that's up, down, left, right. How did I move? What does this tell us? Which way did we move?
Left 6, down 4.
Then the last question you ask for is, was there a negative? Was there a negative in this problem?
Yes.
Yes.
Where is it at?
With the X.
In front of
With
the
the
X.
X.
Yes, and remember you do the opposite. If it's with the X, it's a reflect Y. If it's with the X, it's a reflect Y.
If it was with the 2, would it be x-axis reflection?
Yes, I'm about to do one just like that. Everybody good? So far, okay.
So what if it was on the exponent, it was x minus 6 instead of negative x plus 6?
Right, there's no reflect on that because it has to be the X being negative or the 2 being negative.
Okay.
This just tells you, does it go left or right? So if it's a minus, we pull it out, it becomes a positive and it would go right 6. So that doesn't reflect at all.
Yeah.
Okay. Y equals negative 4, absolute value, X minus 1, minus 10. Sorry. What type of function?
Absolute value.
What's your vertex point?
1, negative 10.
Change the X, keep the Y. Everybody okay with those two things? Those are the easy ones. Your vertex point tells you your movement, left, right, up, down. How did I get to 1, negative 10? What way did I go?
Right 1, down 10.
Right 1, down 10. Now, where is your negative?
In front of the 4.
This is a change Y. If we change Y, that is a reflect X. So this one was change X, reflect Y. So if it's on the front, it's a change Y, which means reflect X. If it's on the X, it's change X, reflect Y. Okay, and you guys may not see that with that negative there because remember we put it out front. Sorry, that didn't work. Let me do it down here. We had this yesterday. When we changed Y, I put the negative with the Y. This function would have looked like this. And then what did we do? We divided by negative 1. So that's why that negative 4 means a change Y. So we get Y equals negative 4, X minus 1, and then that minus 10. So maybe that puts it a little more in perspective where we did it like our notes. So again, a number in front, a negative in front is a change Y, which is a reflect X. Last one What kind of function is this one?
Quadratic.
Quadratic. What's your vertex point?
-2, 1.
Mm-hmm. How is that movement? What's that left down, up, right? Left down, yeah.
Left 2, right 1. And up 1.
Good. Okay, left 2, up 1. Is there a negative with the x or is there a negative in front?
With the x.
X.
So this is a change x, which means what?
Reflect.
Reflect y. This is what you were doing on your quiz yesterday. Better or no?
It's better.
That's better.
All right, so I'm going to open it back up, and what I think I'm going to do is I'm debating. So I'm thinking that tomorrow may be more of a work day and get kind of caught back up and open up all 3 of the quizzes that we've taken for you to try again if you don't like your grade. Now, if you got 100, obviously you don't have to do it again. But if you got anything less than 100, I would suggest that you do that. So you may want to go in today and write down the answers that you had previously that were correct. So you don't have to do those problems again. It's going to be the same quiz. It's not, I'm not changing it up at all. Does that make sense? Everybody okay with that?
Okay, so tomorrow will be a work day for all the quizzes to go over everything like that.
But I'm going to give you another practice as well with all of this.
Okay.
So anybody that has like all 100s, which I don't think there is, but anybody that has all 100s will just have a work day tomorrow. And I'm going to open up the Zoom at the normal time. So if you have any questions, I want you to get on and ask those questions, even if it's about the stuff that we do today, because there's probably going to be a lot of questions about today. All right. That way, if you don't completely finish your homework or your quiz for tonight, you still have time tomorrow to do it. And the reason I'm telling you to write down your answers is so those quizzes don't take as long. So write down the correct answers and only fix the incorrect ones. It's not like you have to take the full quiz over again, unless you got a 0, but nobody got a 0. Is everybody okay with that?
Yes.
All right. All right, so your notes today look like this. And again, I said you might need paper, y'all, I'm sorry. You might need highlighters. If you have a different color, you have a crayon, it don't matter. Just as long as you have a different color, it'll help. So we're gonna start with this first graph, and it's -2x plus 3. What kind of function is that?
Linear.
It is a linear, so we're going to have a line. But what we're going to do today is we're going to domain restrict, which means that if we're looking at the graph, if we're looking at the graph, we might not graph the entire graph all the way across. We're going to stop it at some X point. So the domain represents the X value range. So how far it goes from left to right. All right, so this first one has f of 0. Do you guys know what that 0 means? What does it mean to have that 0 there?
Y equals 0.
Not y, but
X equals
x. It replaced x in this. See how it's f of x and now it's f of 0? So this just means that x equals 0. So what we do is we're going to plug that in. -2 times 0 plus 3. We won't do this every single time, but I need you to know why they told you to do that. -2 times 0 is 0, plus 3 is 3. That means that we have a coordinate of I plugged in 0 for x, and I got 3. Sorry. No, Caitlin, no practices. You guys can do those for extra work, and I do the practices like when we do private Zooms or we do Zooms after class is recorded. So y'all don't have to worry about that. Just quizzes are the only thing that you guys are responsible for turning in, okay, and completing. All right, so we're gonna graph f of x. So we're gonna graph this equation But it says this right here. X is greater than or equal to 0. What this is a boundary line. That means we're going to stop that graph on that line. We may graph on the left or we may graph on the right. Who knows? It'll tell us, but that's what it's for. So what I do is I take my highlighter, and where X equals 0, that's actually the y-axis, I'm going to highlight. I'm going to grab a different one. But. Okay. So that's my boundary line. Something's going to happen on that line, and something's going to happen either to the left or the right. How do we know which side of the graph we're going to do? This inequality says it needs to be greater than 0. So which side of the graph is greater than 0?
The right.
So we're going to graph this on the right. The other thing it tells us is that it's equal to, so the equal to is going to make a solid point. So we're going to fill it in. So no open circles on this at all. All right. The reason they give us this point, that 0 that they put in there, is from the f of x. X is greater than or equal to 0. This is our boundary point. Okay, this is our boundary point. So on our boundary point, we're going to have a solid dot. So 0, 3, fill that dot in. And then which side did we say we're graphing on?
Right.
And our slope is?
-2.
So how do I graph -2?
Down 2 over 1.
Down 2, right 1. Down 2, right 1. I like to go all the way across my graph, connect the dots, and that's it, guys. So now you just boundary restricted. It's crazy to begin with. It gets better. Okay, so the more we do, the better it gets. Again, I have time, but if it cuts out, we'll come right back in. So don't stress out. I'll record both parts and post both parts. All right, so check the next one. We're going to do the same exact thing. Okay, what kind of function is this though?
Quadratic.
Quadratic. So we're going to make this one our boundary point at 4. What does this mean do, this f of 4?
X equals 4.
Perfect. We're going to plug in 4. So 4 minus 3 squared, and then minus 4. Remember, all this is doing is giving us our boundary point. So what's 4 minus 3?
1.
Squared.
One.
Minus 4.
-3.
So your boundary point, we plugged in 4. We plugged in 4. We got -3. That's your boundary point. Where is my boundary at? Where do I draw my boundary line?
Four.
Mm-hmm. So I'm going to take my highlighter, and at 4, I'm going to make the boundary line. Yeah, that shows up a lot better. Perfect. Is my point on that boundary line, remember this is your boundary point, is it going to be open or closed? See how this doesn't have an equal? Right. This means open. So at 4, -3, I over exaggerate it so you can see it. I'm going to have an open point. What else does this tell us? Which side of the graph are we going to if it's less than?
Left.
The left.
The left. So we will not graph on this side. This side should stay empty. You don't have to color that in. I'm just trying to give you a visual. But now I need to graph the other side. Listen, I'm not trying to make you work really, really hard. So what I do is I take my calculator and I go into y equals, and I put this function in, x minus 3 squared minus 4. Is everybody good? They can see it? And then I go to my table and I get my coordinates that are on the left side of 4. So 3, 2, 1, 0, so on and so forth. So 3, negative 4. I'm going to plot that. 3, 1, 2, 3, 4. And then I have 4. I did go keep going up. 2, negative 3. 1, 0. 0, 1, 2, 3, 4, 5. And then I can't do the other one, but now I connect the dots. And that's it, y'all. So you're still graphing normal, you're just not graphing one side of it. All right, so let's go over this again. Why do we put our boundary line here?
So you know you don't cross it.
Okay. Where did it come from? It came from this.
The 4.
What does this inequality tell me? 2 things.
Tells you the left or right side of the boundary.
Okay. Why does this one tell me left?
Because it's
Because
less
X
than.
plus
Less than. Less than is to the left. Greater than is to
Right.
Right.
the right. What about the actual point?
It
It's
tells you
opposite though.
Open because there's no equal mark. If it had an equal mark, it would be closed. So those are the things that you need to know. They're being nice by giving you the boundary point. Okay, they're being nice on this. Typically, you're gonna have to find it on your own, and all you do is look on your calculator. So if it didn't give me that, I'm looking for wherever the 4 is. So my boundary point is 4, negative 3. You don't have to find it in your head, okay? So if we're looking at this one, what's different about this one?
there's 2 X things.
Yeah, so what do you think you do?
Subtract them.
Both of them.
Yeah, you do both of them. So negative 4, 1, 2, 3, 4. And negative 1. Where does the X fall in this statement? Where is the X? It's not a trick question.
In between.
In between them. So where do you think the graph is going to fall?
In between the
Yeah,
line.
so we're not graphing either side here. Does that make sense? Now, they give you the boundary points, negative 4 and negative 1. I'm not going to plug these in because I'm going to show you how to do it on your calculator. Put your function in. What type of function is this?
Quadratic.
And I'm going straight to my table. I'm going to look for this first boundary line. Okay, so I'm looking at this one on the left first, right here. What happens at negative 4? What does this tell us?
X is greater than and equal to.
But what's the equal to tell us?
Closer.
Closed.
Closed. So on negative 4, it's going to be closed. Closed on negative 4. Can you guys see my calculator and see what the coordinate is for negative 4?
One.
So I'm going to graph that. Negative 4, 1 is a closed point. And again, I over exaggerate so that you can see it. You don't have to make your points that big. We're going to graph everything between until we get to negative 1, and then we'll talk about the negative 1. So negative 3, 0. Negative 2, positive 1. And then what happens at negative 1? That's my next boundary. What does it say over here?
It's an open circle.
Open at negative 1. So my coordinate is negative 1, 4. And again, I over exaggerate for you guys to see. We open it up. That's it. So your calculator will give you everything that you need. You don't have to graph them. You know, I mean, you got to graph them by hand, but you don't have to be crazy about it. All right, we're going to do another one. Don't stress out. We're going to do another one. Everybody got this one? I can move on? Yes?
Yeah.
Okay. I'm going to go into my y equals and I'm going to put my function. What kind of function is this?
Absolute value.
Yep. And I'm going to just go to my table. I don't need anything but my table. I don't care about the graph. So where are my two boundaries?
-3 and 5.
So -3, 1, 2, 3, 4, 5. What's that tell us I'm going to do if there's two boundaries?
The x goes in between. So
Mhm.
you grab between.
We don't have anything on this side. Again, you don't mark those like that. I'm just doing it for visuals for you. All right, so what does this inequality tell me?
Open circle.
Open.
On what?
The -3 boundary.
And where is that at? -3 what? What's my coordinate for that?
-3, 1.
Yeah,
One.
what's my calculator? -3, +1, you said was open. And again, I over exaggerate it. What's this side tell you?
Closed circle.
Close.
At?
-1.
Nope, not at -1, but
5
I got where you're getting that -1. Yeah, closed at 5, -1. So 5, -1 is closed. How do I finish it out?
Graph the points in between.
Yeah, so we're gonna go from -3 to -2, 2. So -2, 2, -1, 3, 0, 4, 1, 3, and you guys can get the pattern from there. And again, make this one super tight V-shaped, okay? Super tight V-shaped. All right, so let's talk about this for a minute. What this does is it changes the domain. Remember we talked about regular graphs, like regular quadratics, the domain was negative to positive infinity. Well, now it's not gonna be that, okay? Now it's not gonna be that. What would be the domain for this graph, this first one? How far to the left does it go?
0.
Is it included or excluded?
Included.
Why is it included?
Closed dot.
It's closed. How far does it go to the right?
Infinity.
Perfect. And that is not included. Look at your range. Remember, range is lowest to highest. What's the lowest it goes?
-infinity.
Negative infinity, which is not included. How high does it go?
3.
3. Included or excluded?
Included.
Included because it's a solid point. Not too bad, right? You guys are good with domain and range. Y'all did pretty good on the quiz with domain and range. Some of you mixed up the coordinates. So instead of putting 3, you put 0 right there. All right, what about this one? What's your domain? How far left does it go?
Negative infinity.
How far right does it go?
Four.
4.
4. Included or excluded?
Excluded.
So parentheses, because it's an open circle. All right, look at your range. How low does it go?
-4.
Included or excluded?
Included.
Included because that point is solid. As we move up, we see a hole, but we have a solid point right next to it, so it cancels out. We don't worry about it. How high does it go?
Infinity.
That's it, y'all. That's it. Are y'all good with domain and range, or do I need to do the other two?
On the domain, why is the 4, why does it have a parentheses instead of a bracket?
Because what's happening on our boundary? Is it open or closed?
Open.
Open, so we open our parenthesis.
Okay.
This is closed. Solid points have brackets, opens have parentheses. Okay, everybody okay?
Yeah.
All right, check these out. All right, same thing on this one. But these are special functions, okay? These are special. So if we look at this, where's our boundary?
-5.
Look at this graph one more time. Which one shows our boundary? This one, right? 1. How is this different than the other ones? Real fast.
It don't have a less than or greater than. It's just a equals with the slash through it.
So all this means is not graphed on the boundary or open on the boundary. But we graph everything else. Okay. What kind of function is this?
Exponent.
Exponential. So when we look at our table, our boundary line is at 1. So my coordinate for that 1 is negative. Did I type that in right? 3 to the x minus 5. Yep. All right. Oh, I don't like this one. Oh, and 1 is -2. Does everybody see that? 1, -2. We open that up. 1, -2. But then we graph everything else the same. So we're going to graph every other point. 2, 4. We can't graph 322. We can go backwards, but what do you see? What does it stop at?
5.
5. That -5, 1, 2, 3, 4, 5, is that horizontal asymptote that we've been talking about. So what it does is it comes real close. Don't cut through your circle. And then make it go up. So just don't graph the boundary point. So if it's not equal to, don't graph the boundary point. All right. So this other one has equals 3, right? So what this means is only graph the boundary point. So these are kind of special. You don't typically get these. And your boundary is at 3. What kind of function is this?
Linear.
Yeah, it's still linear. It doesn't have the x because it's a horizontal. So it says only graph the boundary point. Since it's equal, it's going to be a closed point. And I went way down, sorry. We're looking for 3, 5, 4, 3, 2, 1, 1, 2, 3. What's my coordinate at 3? 3 what?
-2.
It's going to be a solid point, and that's the only point you graph. That's it. All right, so I have exactly 5 minutes left. I want to do domain and range of this. If we don't get to the last 2, again, pop back in and we'll finish it up. So let's do domain on this one because some of you had trouble with this type of domain and you're going to have it on your test. So this domain, how far to the left does it go?
-infinity.
Negative infinity. We bracket that, parenthesis that. As we go over, you guys see this hole? We have to stop at the hole. Where is that hole at? What's your x coordinate?
1.
That 1, it's a hole, so it's a parenthesis. We have to keep going because there's more graphs, so we put a U, and you guys did that part well. You pick back up at the same place you left off, always. For right now, that's always the case. Then how far will it keep going to the right?
Infinity.
That's your domain. Again, this is what you're missing. You're not picking back up where you left off. Look at your range. What is the lowest this goes? This graph cannot go below what?
-5.
-5.
And because it's an asymptote, you have to use a parenthesis because it's not included. As you go up, you see a hole, right? Where is that hole at?
-2.
2.
Yeah, and it's open because there's nothing else there that'll touch it and fill it in. So we have to close it, open it at -2. Where do we pick back up?
-2.
-2. And then how far up does it go?
Infinity.
That's it. Okay, one more domain and range, and then we're gonna be stuck. Okay, one more domain and range. This one, guys, I'm telling you right now, this is gonna be on your test. Okay, something like this will be on your test. What's your domain? If it's one coordinate, this coordinate is 3, -2. Domain deals with X, range deals with Y. So what's your domain? Try
3.
3. Brackets or no?
Yes.
Yes.
Yes, because it's a closed point. You don't have to repeat that number. Just leave it as 3. That's all you do. Range, I'm telling you, this one's going to be on your test, something like this. What's your range?
-2.
And that's it. Any questions? All right, so I'm going to start this one and then we'll have to pick it back up. I have 2 minutes left. All right, so this kind of follows through everything. Actually, let me stop and go back in. So I'm going to go ahead and stop the recording. I don't want to break it up. Stop the recording.